Hi guys, my name is Arvind Kumar and welcome to my YouTube channel NetworkGrid. In this tutorial, I will explain network topologies and architectures. It's hierarchy that help us understand where things belong, how things fit together, and what functions go where. Hierarchy helps us summarize a complex collection of details into an understandable model. Hierarchy is nothing but designing a diagram and then understanding where which device functions at which level. The Cisco three-layer hierarchy model, three-tier. The Cisco three-layer hierarchy model is also called as three-tier. The Cisco hierarchical model can help you design, implement, and maintain a scalable, reliable, cost-efficient hierarchical internetwork. Each layer has specific responsibilities. Keep in mind that the three layers are logical, so they aren't necessarily a physical devices. We may have many devices in single layer, or they may be a single device performing function at two layers. Just remember that the definition of layers is logical, not physical. So Cisco maintains three-layer hierarchical model. They call it as a three-tier also. As you can see in the diagram, you can see the topmost layer is core layer, where you find routers, firewalls, and backbone routers. And in the distribution layer, you can find multi-layer switches, where it performs ACLs. It also has route functionalities. It also has security properties. And where you place these switches is called as distribution layer. And in access layer, you connect your servers, your PCs, and your switches, where you create VLANs, where you connect your PC Ethernet cable directly to the switch. So why we are segregating this hierarchy into three layers is to identify the issue very simply. So if you divide the layers and then go for a troubleshooting, that would be an easy step. That's the reason Cisco follows three-tier hierarchy or three-layer hierarchical model. There is also a two-layer hierarchical model, but that is actually to reduce the cost to the companies. Both uh, distribution layer and core layer forms together a single layer, and access layer is a different layer. So that's how it became a two-layer technology, but I did not mention in this slide. So let's go and understand more briefly about Cisco three-layer hierarchical model. So now let's speak about the core layer. The core layer is literally the core of the network. At the top of the hierarchy, this layer is responsible for transporting large amount of traffic both reliably and quickly. The primary purpose of the network core layer is to switch traffic as fast as possible. The traffic transported across the core is common to majority of users. The traffic which is transferred in core layer is it belongs to the users. But user data is processed in distribution layer. That is what they are saying. User data is processed at distribution layer, and the information which is transferred in the core layer, it majorly belongs to the users. If there is a failure in core, if there is a failure in core layer, every single user in the network can be affected. The core is likely to see large volume of traffic, so speed and latency are driving concerns here. Let's start with things we don't want happen here. Never do anything to slow down the traffic. They are saying never do anything to slow down the traffic in core layer. This includes making sure that you don't use access list. Access list is to avoid the traffic based on IP addresses or port numbers or specific things. Do not create virtual local area networks in core layers or implement packet filtering. All these things should not be done in core layer. So don't get confused by looking at different things like access list, performing routing between virtual local or area networks, or implementing packet filtering. Going forward, we will discuss all these topics. Okay. For now, just remember, do not implement such kind. You can implement these in core layer. No one is stopping you, but it is recommended not to use those functions in core layer because we need a speed and latency should not occur there. That's the reason we are it's recommended that not to use access list or routing or implementing a packet filter. Now let's go to the next line. Don't support work group access here. Don't support work groups. It's another technology that we can use, so don't use that work group access here. Avoid expanding the core. Example, adding routers. As an internet network grows, it performance become an issue in the core. Go with upgrades over expansion. So what they are saying, if your network is growing, do not add an extra router. They are asking you to upgrade your router. You can find a better router from Cisco, and they are asking you to buy that router instead of adding another router in the core, firewalls in the core. Goals we want to achieve as we design the core. Use a gigabyte ethernet with redundant link, or even 10 gigabyte ethernet. Design with speed in mind. The core should have very little latency. Select routing protocols with lower convergence time. Fast and redundant data link connectivity is no help if your routing tables are short. So they are saying that use 10 gigabyte ethernet. Thinking about speed, you need to select routing protocols which are having lower convergence time, which will respond fastly. And they are also saying that less routing table is the disadvantage in core. So let's go to the next slide and understand about distribution layer. The distribution layer is sometimes referred as a work group or aggregation layer, and is communication point between access layer and the core layer. The primary functions of distribution layer are providing routing, filtering, and WAN access, and to determine how packets can access the core if needed. The distribution layer must determine the fastest way the network service requests and handles. It is said that the distribution layer must determine the fastest way in the network in order to transfer the packets, or in order to handle the requests. The distribution layer is where we implement policies for network, because we have a lot of flexibility in defining network operations here. Several things that should generally handled by distribution layer is routing, implementing tools like access list, packet filtering, and queuing, implementing security network policies including address translation and firewalls, redistributing routing protocols including static routing, routing between VLANs and workgroup support functions, defining broadcast and multicast domains. All these things should be done in distribution layer. So let's go to the next slide and understand access layer. The access layer controls users and workgroup access to internetwork resources, and is something referred as desktop layer. Why we are calling it as a desktop layer? Because you connect your desktop in access layer. Most users need is basically available in distribution, right? If we wanted to move from one network to another network, that particular work is done in distribution layer. That is what they are saying. If they need a remote access, the request comes from distribution layer to access layer, is what they are explaining here. Here are some tasks that access layer carry out. Continued from distribution layer, use of access control list. If you configured access control list in distribution layer, it will get the request from distribution layer. Creation of separate collision domains and micromanagement management and switches. Obviously, collision domains and micromanagement are done in access layer. Workgroup connectivity into distribution layer. Workgroup connectivity in distribution layer is also done in access layer. Device connectivity, you will connect your device in access layer. Recover quickly from difficulties and security services. Advanced technology capabilities, voice, video, etc. QoS, quality of service marking, is also done in access layer. Gigabit or fast Ethernet switching are frequently seen in access layer. So remember all these things. The terminology which you are seeing here, like access control, policies, all these are different subjects or topics that we're going to discuss in future videos. Now talk about a spine and leaf. This is another architecture or a topology or a hierarchy that Cisco or other companies are using. Today's data centers demand a new design, and one was finally created that works really well, called leaf and spine technology. Don't get confused with name, because it is called as spine and leaf technology or leaf and spine technology. How it works? First, let's understand how it works. Data center has racked with several servers. You can see the image. These all blue color lines are called as servers. In the leaf and spine design, there are switches found on the top and end of each rack that connected to these servers. So you are finding a switch on the top of the rack, and underneath it you are also finding another switch. This is how data center requires the design. They connect all the servers to both the switches, because for redundancy, if one switch is failing, it will take the path from the other switch. So that is what they are saying. You will find a switch on the top. Basically, in normal hierarchy, you will find a router or a firewall on the top core layer, but here you will find a switch, and all the servers are connected to the top switch and the end switch for redundancy. Okay, with the server connecting into switch for redundancy. As I said you, these servers are connecting the top switch as well as the lower switch for redundancy. People refer this type of rack as tor, top of rack. For short, they call this as tor rack or tor switches, because top of rack switches. These tor switches act as leaves. So these tor switches are leaves. So they are calling this as spine and leaf technology. Now let's understand by looking at a diagram how spine and leaf technology are connected. You can see each leaf. These are leaves, don't get confused. These are leaves, as we discussed. These are tors, these are leaves. You can see each leaf switch connected to every spine. Each leaf switch is connected to every spine with two redundant links, and they connect to both spine switches for redundancy. Redundancy is nothing but if one link fails, it communicates over other links. If one switch fails, it communicates over other switch. So this is how spine and leaf technology is designed. These both switches with red on it are called as spine switches, and these switches which are placed in the racks are called as leaf switches. When this particular hierarchy is maintained in data centers, all the leaf switches will be in a same distance. Let's say if one leaf switch rack is maintained at 100 meters distance, other three leaf switch racks will also be in 100-meter distance only, because they are maintaining redundancy. And you can see each leaf switch is connecting two spine switches. You can see, you can check the image. See, for the redundancy, every leaf switch will connect spine switch, and these two spine switches are also connected with two cables for redundancy. As you can see, it's a Cisco Nexus switch, and this is called as spine and leaf design. Now let's move to the next topic. We'll understand the difference between LAN and WAN. LAN is a computer network established with a small geographic area, such as house, office buildings. So yeah, basically, let's say that you have a router in your home, and that router is having 4 to 5 ports. All those 5 ports are connected to computer, laptop, printer, and Xerox machine. So this is called as LAN because it is locally located in your area, local area network. Now let's understand about WAN. WAN on the other side is a computer network that covers a broad geographical area. LANs allow users to transfer data faster, whereas WAN have comprehensively slow data transfer rate. Now, when we discuss about the WAN, it is connecting geographical areas. I mean to say geographical areas. When you say geographical areas, that I have a network in United States of America and another network in India. These two locations are located at geographically different places. So, in order to connect these two things, we are using wide area network, WAN. So let's understand more about WAN now. Basically, everyone knows about LAN, local area network. For best example for LAN is internet shop, where you find several computer device connected, where you can find Xerox machine connected, where you find printer machine connected. Managing that particular network is called as local area network. We are not talking about how the connectivity is coming to local area network. We are talking about LAN and WAN. We are understanding the difference between LAN and WAN. WANs use the service carrier like telco, cable companies, satellite systems, and network providers. Obviously, when I say that my company is located in India and other company is located in United States, I can't stretch a cable from India to United States, right? We use the medium called internet. Also approach service providers. Like, who are our service providers? Let's say for me, service provider is Beam Telecom. I can connect the world using my service provider Beam Telecom. In the similar way, they are saying that wide area networks use service carriers like telcos, telecommunication networks, cable companies like Beam Telecom, or say Hathway is a cable company, and satellite system. When you say about satellite system, Geo is providing you a satellite connectivity, so that's a satellite system, and other network providers. All they are network providers. WANs use serial connection of various types to provide access to bandwidth over large geographic areas. I have pasted a snip. You can see the serial cable looks like this. So if you want to become a service provider, this is the topic that you need to know. Okay, so we'll speak about all the terminologies: local loop, DMARC, CSU, DSU, and CPE, and this is your corporate. Okay, now let's talk about CPE. CPE is defined as customer premises equipment. Customer premises equipment, CPE, is an equipment that typically owned by the subscriber and located on the subscriber's perimeter. Let's say you are a company and CPE is located at your company, because it's a customer premises equipment and it is owned by you. Now let's speak about CSU and DSU. A channel service unit, data service unit, is a device that is used to connect DTE. And what is DTE? Digital circuit like T1 and T3 lines. A device is considered DTE if it's either a source or a destination for digital data. For example, PC, servers, and routers. In figure 13, the router is considered as DTE because it is passing data to CSU, DSU, which will forward the data to the service provider. So in this case, this customer premises equipment is also called as CSU, DSU, because it is providing information to CSU and DSU. It's transferring the packets to CSU and DSU. CSU DSU provides clocking of line to the router. So it is demarc is a point. Let's say you find a huge box outside your premises in India, which is installed by BSNL, where they connect all the telephone lines. In a similar scenario, they maintain a demarc, which is responsibility of uh, service providers, where it ends. From there, they'll give you a cable where you'll plug into and you'll connect to the internet. So nothing but DMARC is a place where all the connectivity happens. Let's say that Beam Telecom provided you a connectivity. Before providing you a connectivity, you can see a box on the pole connecting several different users. So from there till there, it's their responsibility to maintain the line, and from there they'll give you a cable which will connect into the internet. So that you can call as DMARC, for example. Okay. And let's talk about local loop. The local loop connects the DMARC to the closest switching office. This DMARC is obviously connected to the closest service provider. That particular point is called as local loop. Let's say Bharti Airtel provided network to many people in India. They from Bharti Airtel network, there are many new service providers coming up. And there is a point in Shamshabad, there is also a point in Hyderabad, there is also a point in Secunderabad. The major service provider is Bharti Airtel, and the local service providers like Zoom Internet or Fast Internet, all these are connected to the local loop. To simply understand, if you want to go through rest of the things, you can go. And yeah, and service providers, they mainly use BGP or ISIS. These both are routing protocols which actually transfer the packet from one geographical location to another geographical location. In my future videos, I'll try to explain them if possible. And that's all for now for this video. If you understood what is the difference between WAN, LAN, and if you understood that Cisco maintains a three-layer hierarchy: core, distribution layer, and access layer, and what should be implemented there and what should not be implemented there, please give a like, subscribe, and share the video for more content. Thank you.